test case. So wherever you are setting up the analytics in the IoT end, okay, you require to first of all have your knowledge, right? Your knowledge will come from your data, which is already captured and is analyzed by the domain expert, and then you are using the data to train the models. Okay, you can do in an unsupervised mode also, right? Okay, on the feature based separation of your data, and you can also form clustering type of approaches to build up your model. So either you are going with a supervised type of model, or you are going with an unsupervised type of model. But before starting the analytics, or before making the system on the run, right, you need to prepare your model. You need to validate your model to some test data, and to some standard error metrics, okay, to some iterations, right? And then you settle the model, and then you push the model in the different levels you want, right? It can be the analytics at the agent, it can be analytics at the fog, it can be analytics at the cloud. But depending on the where you are building the analytics, you need to take the consequences what you are into. Right, you have to take the type of data you are trying to work out. You have to take the volume of the data, the latency, the analytics you want to churn out in the different stages of this network. Right, and that's so important in this particular theme. Okay, so I will not go much into the time. And these are the different type of data structures you can go through. Okay, that means there are different types of data structures you can build. At the back end, in the back end is basically the sensor data. So you correlate the sensor data with the timestamp, right, and a node ID, right, and that data packet can now be forwarded to the fog. Okay, and then in the fog, the data is stored from multiple nodes, and this is what is the fog analytics, which is pretty similar to the IoT analytics. Also, you need to build a learning model. You need to work with some sort of supervised or unsupervised data which is already there, and training data, okay, that or a sort of unsupervised model you work, and that you build the model and deploy it. But what is more important is that I want to show you the data structure which works in the fog node. In the case of fog node, the data which is coming from the IoT nodes are then stacked with the IoT node ID. So this is the sort of data structures you try to build at the fog end, because at the fog end the data will come from a different IoT node. So your IoT node data packet will be something like this, and each of the IoT node data packet will be now aggregated at the fog end, right? And that you have to understand. Obviously, what you need to do with the data, obviously, you need to work with a standard machine learning technique to generate the model for analytics. It may be some sort of feature reduction based on PCA. Okay, if you are going going a model like that, it may be feature reduction into PCA, and then classification model based on SVM, and then you try to reduce the error and try to make your model better and better, right? So this, I'm not going into details of all this, and this is what is the way you can deploy the learning models, and that means which work hand in hand with the data you communicate with each of the layers. So these are the standard techniques you can build up. So you can build a fog with your Raspberry Pi models. You can build that means you can use a Raspberry Pi which can work both as a DAC and a fog. Because they're pretty strong in terms of memory and the processing capability. If you're working with the nodes like Arduino, they are mostly suitable for the IoT nodes. But if you have the Raspberry Pi, you can also build them as your fog nodes. Right? It has a stronger processing capability and memory capability than a standard Arduino nodes. Okay, and this is the smart app based model. So what you can do, as I told, that you can also build any smart device, your smartphone. You can have, and that also can work as a gateway. So many applications we have worked with different type of medical experts and environment experts. They told that this type of apps becomes very handy. So you can just have deployed some nodes, and this node data can come to your smart device. You build an app on the smart device which can do some sort of run some analytics based on some model, and can generate a good insight of the data, right? And that Okay, and those type of experiments you can well do, and those type of applications are very well appreciated. Now, suppose the case of smartwatch. You know that many of the smartwatch applications are connected with your smartphone, right? So the smart app in the smartphone collects the data from your smartwatches, and then you can use that to communicate with the cloud, or to communicate with your medical center. So these are the application scenarios which you can play with in this domain, right? And you can build up very effective applications. So I will not go into much details due to this, and this I am going to the one of the work what we have done by the MIT Ministry of Electronics and Information Technology, Government of India funded projects, where we had actually have handled systems which can give you the water quality, which can assess the water quality. Right, this was a project which is supported by METI for our lab, and we have deployed this type of systems. Okay, and we have worked in the rural areas to collect the data and to enrich the machine, the learning model in our device, and now it is doing pretty good. These are the things what we have done. So these are my IoT nodes, and these are the sensors which gets into a particular water bucket. So we have to collect a water sample, and the sensors takes the data, and then the IoT node you push the data to the fog node, and the fog node can be your smartphone, right? And then the analysis starts, and the classification works out, and it tells that what is the class of the water. So the way we have done this is that what we have done, we have actually taken a large varieties of water qualities which are available in a rural area, right? And we train the systems first, and then in the runtime we can give me a water sample, and I can tell that which grade of water it is, right? And similarly, I'm not going details. And similarly, this is also what we have done in the food quality, which is basically for the storage houses, right? In the warehouses, a lot of fruits gets perished. They are perished due to the with time. So to save those, okay, we have developed this IoT, the handheld IoT based sensors, okay, which can also classify based on the data, which is temperature, humidity, and the gas. So the gas data gives you some sort of carbon dioxide gas. The carbon dioxide gas means there is some sort of biological activity going in that particular food, right? And that means that it is going to be rotten very soon. So these are the things which we try to detect to our sensors, and then again it is a sort of process flow which actually connects it to a DAC, to the cloud, or to the fog, and we can do a very real time analysis of a large area where fruits are stored. So this has been patented. We have filed an Indian patent on this particular activity of this food monitoring system, and it's not only food. It can be done for any edible food item, because any edible food items can be attacked by the bacteria, and when they get attacked by bacteria, the oxygen level decreases, the carbon dioxide level increases, and that's actually gives you a clue. That means also the humidity level also increases, and that gives you a clue that it is now getting attacked by some microorganisms. So this is the work what we have done, and lastly, I didn't able to cover this part. This part also we are working very very heavily. That means as these applications can be very important applications, maybe from health to food safety to transportation. Okay, so you need to have, that means, an end-to-end security model which needs to be placed in this particular IoT network, and that is a challenge because the security protocols are pretty heavy. They require energy. They require computation power. So how to save computation power, but also can employ the security which is required in terms of authentication, in terms of data integrity. That is very much required in this particular domain, and that's the work what we are also doing. But due to limitation of time, I cannot explain that in this particular lecture. Okay, but this is a very important aspect, and I think you all can. That means many of you can be interested in this particular aspect of IoT too. So last but not the least, I want to say that this is a particular topology what we try to discuss with my senior professor at Kyushu Institute of Technology, IEEE fellow Professor Wen, when I stayed there for a couple of months as JSPS visiting professor, and then what I tried to look into the problem as that the problem in IoT, and I will be very open to any researcher or that means or any of the students here. That means I'm very open to work on this aspect of IoT. So there are three axes of IoT. One is the devices. There can be different types of devices in the IoT domain. There can be different types of application services in the IoT domain, and there can be different types of connectivities in the IoT domain, right? And each of these requires a different types of security aspects. The problem in the IoT is that, as we know in the security, it's a connected device. So any door open makes the other doors also vulnerable. So in the IoT, this is to be very taken very strongly that if you are working in a connected world, in a connected devices, you cannot make any device vulnerable. One device vulnerable will generate some paths for the other device which you perceive they are very strong. So that is one of the aspects of this. So attacker actually tries to find a weak device, and through that it tries to penetrate and tries to get into the other devices also. And that can and to consider these are the health, these are your disaster management systems, these are your power management systems. These are agricultural food safety type of applications, and it can cause a disaster to all of us. That's why we need to be very very careful, and we need to think on this axis. So the three axes is what is there, and that is the motto of security, is that for a particular scenario you have to generate a particular type of power, right, which can give you a threshold or trade-off in each of the parameters, okay, in terms of connectivity, in terms of device specification, in terms of application space, and can also give you a sustainable security, right? And that's what we I think it's very very interesting domain of research and activity in this particular domain. So these are some of the projects what we are trying, what we are doing. We are actually done with our these MIT funded projects. We are continuing our work with a project funded by Department of Science and Technology, Government of West Bengal, on the food, on the visual sensors, agricultural smart techniques for agriculture. We research grant this year, and where the research problem she will be working on basically the security part of this IoT framework. So this is all. And last, I want to say that that means there are two beautiful philosophy. One is from Buddha, who tells that that everything is relation to everything else, right? That was told by Buddha, and that is what is IoT. So every device is now related to every other device. And our Advaita philosophy also tells that we are in an interconnected world, though individuality also remains. So that's also a fascinating view of IoT, which tells that you have connected devices. The devices are being collaborating with each other, but also doing their own tasks in a very efficient way, right? And that's the philosophical part. What was there in our scriptures, which can be well thought or can be well visualized in the IoT domain also. So I end up here. Sorry for the interruption which happened in between, but I hope that means I was able to transfer the message what I intended to do. Okay, and I will obviously send the presentations right to the organizers. You can go through that, and you can come back to me obviously later. But any other questions, I will be fine to answer.
Thank you, sir. Thank you, sir, for this lovely presentation. Almost the broad idea of starting from the very beginning and the vast applications of IoT. So yeah, so we will take some questions if anyone is having some questions. So in the chat box, we are getting one question from Ms. Richata Parvi. She's asking that when is edge computing or fog computing a better choice than cloud computing for which specific use cases?
Okay, so I will tell it's only the latency you need to look towards that. So what is the latency? Okay, so edge computing gives you the least latency, but you cannot process very complex tasks on the edge still now. Though people are trying to push FPGA type of systems at the edge, and we are also that our group is also strong in FPGA. We are also trying to push that in the edge, but provided the edge requires that means edge means on-field operation. So in on-field operation, you cannot deploy very heavy in the practical aspect, because when I just visited a fisherman's village, they told that was we want to deploy some sort of smart small boats. So small boats will have sensors and they will float around the water and they will collect a lot of data. So when I told this to fishermen, they will tell that, sir, you are perfect, but in the morning you will find the boats are not there in the field. So people will think they are toys and they will take back into the home. So there are some risks, okay, in the reality. You can do it in an industrial setup, right? You can do it in an industrial setup. You can push a lot of complex hardware. So you can, and the VLSI, and due to the present VLSI technology, you can squeeze down the sizes of these devices, and you can have a lot of complex potential. But due to the cost and due to the energy, right, you cannot push very complex stuff at the edge. So if you are going for very low latency, right, edge computing is a good way, but you have to distribute. You have to do a scheduling so that you can have a sort of budget of the tasks which are getting pushed into the edge and which are processed at the fog. It's a trade-off between your resource, energy, and latency, and that's the way we are scheduling.
Thank you, sir. So if anyone is having any questions, you can unmute yourself and can ask straightforward.
Okay, hello, sir. This is Abhishek. I
Yes.
have one a basic question regarding IoT devices. Okay,
Yes.
some existing literature actually accept that a device like smartphone, laptop, this kind of handheld device, actually they are treating it as a IoT devices, and some don't agree with this. So there is a lot of debate between what actually IoT device is. I found a
Okay.
gray area about this, and
Okay.
is there any unique features that defines IoT devices and separate all the devices from in existing network? So what is
Okay.
that?
So that's a very good question, and that's the thing which also makes us confused. This confusion was also there that means we have in the embedded system domain. That means how much we can tell this is an embedded system, right? So how much embedding we can do. So normally we try to tell that device has a particular functionality which is not exactly computing, right? That means you have a device which is basically a data capturing type of system, right? It is not essentially a computer which is there, right? And it should be a sort of handheld, portable, okay, deployable type of device, right? But which maintains a connectivity and which can actually push the data, okay? Which is so it is basically a sensor which can work on field deployment, right? Which can also have a communication power. So normally we try to focus the device level as scanty as possible, okay, to minimize the cost, to minimize the energy, and also to help in the deployment. Okay, but much larger the device is, right? In terms of energy, in terms of cost, in terms of deployment, right? It goes over the budget of what an IoT budget gives you. So that one perspective you can take, that what can be an IoT, what might not be. So IoT is something where budget is not pretty high in the all respect. Okay, in the size, in the energy, in the resource, at the cost. So these budgets are limited in the case of IoT, and it is basically a type of sensing and communication device with a very minimum processing capability. Okay, that's my answer.
Okay, sir. Thank you.
Okay. So if anyone is having any question, you can unmute yourself and directly ask, sir. Sir, actually, one question from my side I would like to
Sure.
ask. Sir, actually, like in this kind of device-to-device or mobile-to-mobile communication. So, for few cases, if we look into this kind of communication, so are we at all need any kind of edge or fog computing devices to communicate between device-to-device or mobile-to-mobile? Like
No,
for which specific cases?
Yes,
or suppose
device to device. Yeah, only if you are looking for communication, you might not need something. But suppose you want to suppose you want to. Okay, so the real example I will try to tell you. So if you go to a village land, so there are a lot of insects. Okay, a lot of polluting water gets into the land, right? And if you are trying to that means if you don't check at the point of time where it needs to be checked, right, it is a huge loss. So the problem in this type of real field applications is that it basically depends on the data you sense, and based on the sense data you need to derive some effort or some decision, right? Now when you take some decision, it depends on your history, right? That means what is your domain expert, the domain expert or the history data. So now you have to correlate the data what you have on field, okay, with some data, and you have to take a decision. So this type of complex task cannot be done only with communication, right? You need to have a sort of sensible, intelligent agent, right, which will be guiding you based on the data, right? And that guidance is given by the analytics, right, which is in the top of this data layer, right, and for which you require this type of edge and fog or cloud, right? If it is only pressing a button and switching on and off, you don't require actually anything. But whether your switching off this is appropriate at this point of time, or you need to press switch 1, not switch 2, or not switch 3. If you have to take this type of decisions, not based on your perception, based on the data which is there on the field, right, you have to run the analytics, and that's why this fog and cloud comes into play.
Okay, sir. Another question I have. This is not like a technical question, sir. Due to this kind of lockdown, we are almost everything we are doing online. But sir, like if we consider kind of village area or overall connectivity, like India or over the world, so we face lots of trouble within data or connection, etc. So, sir, how do you think, like in future, how IoT will help in this kind of like rural area or global connectivity kind of thing to solve this?
So I think you know that the world of 5G and 6G is coming. Okay, 5G is already there, right? Actually, many of the industries like Samsung, like Ericsson, okay, they're Cisco, they are working hard. So once it comes the 5G, so the entire concept of 5G is reliability. So 5G gives you a higher reliability, okay, with a much more speed, right? And those type of, obviously there should be a tremendous push into the backbone networks. Right? Ultimately, if you want to push into the cloud or into the fog, okay, you require the support of the backbone network. So your backbone network should be reliable and should have a good bandwidth to support them, because one should have so many. Though we tell that devices are generating small amount of data, but if you have so many devices, it's a huge amount of data, right? And at the present strength of your bandwidth might not be, you will support that, and your quality of service will go down. So to maintain the quality of service, obviously the backbone, the research or the progress in the backbone network has already been initiated, and we hope that 5G, and you know that the marriage of 5G and IoT is pretty hot now in technology. Okay, that means a lot of groups are now doing this work, and I think this type of technology support at the back end, okay, will actually make a more expansion, okay, of IoT in the scenario.
Thank you, sir. So almost we are running out of time, I guess. Lots of. So if no more other questions are there, so we'll conclude the session. So I guess there is no other question in the chat also.
Yeah, I would like to thank Professor Chakraborty for this wonderful time that he offered us. And he's a busy person.
Sir, before we conclude, sir, we'd like to just take one snap.
Oh, sure, that's great.
So please, all the volunteers also who are present, please turn your camera on, or the participants also if you'd like. And Shamuntogda, please take a snap of that.
Sure, I'm taking.
Okay.
Hi, Devdut. Good evening.
Yeah, it's done.
Just a minute.
Okay.
Okay, so it's going on in 3, 2, 1. Okay, some are coming late right now. Okay, other one in 3, 2, 1. Yeah, it's done.
Okay. Thank you.
Thank you all.
So, yeah, sir. Yes, sir. So, Rajoshi, sir, if you want to say something, you can say.
No, actually, I would like to thank Professor Chakraborty for this wonderful talk he has offered us, and he's a very busy person. But despite of that, he offered us some time, and he shared his time with us. So it was indeed an honor to have him over here. And I just pray to God that this COVID situation go away, and I can travel to his place sometime and maybe meet him in person, and we can discuss things. And whenever he comes over here, we would also try to arrange more talks and more interactions so that our students get benefited. And that's the most important part of it, that the students stay up to date about what is the current cutting edge research going on all over the place, and so that and they have the concepts clear. Okay, this talk that way was very, very illuminating. That it clearly shows that what are the various building blocks are, what are the infrastructural details are, where which piece of software is going to get embedded, and how all these things are going to be managed, and what are the different types of performance challenges, resource allocation challenges, and other associated issues that is involved in this. And it is good to see also that Professor Chakraborty has managed to attract great amount of funding for this kind of projects, which is very much essential if you want to do it in a real scale and in a big scale. And it is very good to see that such works are being done, and he's leading that work and setting an example to us that what is the way the research should evolve and other things. Okay, so I believe that from his work, various verticals and horizontals will come up, and a lot more PhD students and postdoctoral students and other people, they will be benefited from him through this entire mesh structure of the workflow. So I wish him the best, and we also ask for his intellectual support and moral support whenever we need, and I think that it will set the stage for future long and good collaborations. Okay, so this is my most humble request and my humble hope.
Thank you, Professor Roy. I am always open to collaboration. I am always wish to connect with the professors in the various good institutes of the country, and I will be very happy to collaborate and to connect with you all. Okay. And obviously to my dear students, I think whatever they require from me, I will be there to support in this particular domain. Okay.
Yeah. Thank you, sir. Thank you, all the faculty members and the participants, most importantly, for their patience and attending that talk. And also, I would like to thank Rajoshi sir for mentoring the session, and Omlan sir also for his valuable time and sharing his thoughts with us. So, by saying this, okay, one more thing that, sir, we are having one small token of appreciation for you that will be dispersed from the section side.
Okay.
So I will contact with you soon.
Sure. No,
yeah. So by saying that, I would like to
Stay fine and stay healthy, all of you.
Yeah.
Stay fine and stay healthy. That's
Wishing you same, sir, for your side. So that's all for today. So
Thank you all.
Thank you.
Thank you, Professor Roy. Thank you, Devushi. Thank you.
Thank you, sir. Thank you, Professor Chakraborty. Thank you.